Hello my dear students, welcome back to St. Joseph Composite PU College. I am Rahul and in this video I am going to discuss the topic solution. It's the first series of lecture where I am going to discuss the solution topic. The solution is very important topic for your examination. Solution. Very beautiful concepts are there in this topic. We start with the scratch. The known thing about the solution is it's a mixture. Okay. The most of the students know that solution can be formed by a mixture of and even you know that mixtures are two types there, mixture of solute and solvent. This is most of the students know that it's a mixture of solute and solvent. But my part of discussion is that the mixtures are again divided into two parts. I think you know that. The one part is called as homogeneous mixture. The another one is called as heterogeneous. The meaning is very simple. In the homogeneous, the concentration is same throughout the solution, right? So you can say that the uniform concentration, let me write here this part here, it suggests us that uniform concentration. Whereas when you talk about the heterogeneous, the concentration is not uniform, right? So then it is called as non-uniform concentration. Non-uniform concentration. This is very simple. We'll have one example to understand this concept. Assume that I have two containers here. This is the first container. Okay, and here another container I'm taking. This is another container. And what I'll do that in this I'm going to add a water. So there is equal level of water in both the containers. In the first container, I'm going to add the sodium chloride in this. Just any salt you can add. Sodium chloride, I will take NaCl. And I will take sugar also. And in this container, I'm going to add here the one of the insoluble salts like calcium carbonates, or even I can use here the sand. In generally, I'm going to use here sand, or we can use oil. Some oil we can use. What is your observation? In the first case, here the solution get uniform distribution of sodium chloride. Here is the sodium chloride distributed uniformly. So all over the solution, the concentration is uniform. But when we talk about the sand particles get settled at the bottom. They get settled at the bottom. Okay. So if I talk about the concentration uniformity, here there is a uniform concentration is present. Uniform distribution of salt or solute, I will write. In generally, salt is called a solute, right? Solute. And here you can say that at the bottom we have a sand and above we have water, and therefore it is a non-uniform distribution of you can say that here non-uniform distribution of solute. Okay, and therefore we can provide the definition for the solution. The solution is nothing but a homogeneous mixture. It is just a homogeneous mixture because uniform concentration is required. Homogeneous mixture of you can write here solute and solvent. Okay, solute and solvent you can write, but what I suggest that our definition should be more generalized, and therefore what I'll do that is a homogeneous mixture of two or more components. And that is known as the solution. And there are different types of solutions are there. So most of the students know that solutions are liquid. When I ask in the classes, I have observed the same kind of answers that solutions are always liquid. But no, it's not like that. The solutions, types of solution, let me write the types of solution. So in the types of solution, we have three important types. The first one is called as liquid solution. And second one is solid solution. Okay, and third category is, I think you got it, that is third one, that is gaseous solution or gaseous solution. Okay, there are three types of it: liquid solution, solid solution or gaseous solution. On what factor they decided it? And we know that solution containing two components, right? I think one is solute, another one is solvent. Okay. Whatever the three classifications are there, it depends upon the nature of solvent. It means that, so in this case, the solute is here maybe liquid. The solute may be liquid, or it may be gas, or it may be solid, whatever it is. But in this case, solvent should always a liquid. If solvent is liquid, then that solution is called as liquid solution. Hope you understood this. In this also we can make the same kind of statements. In this case, solute, if you take, solute may be solid, or it may be liquid, or it may be gas. But in this case, the solvent, the component which is present in a larger quantity, and that should be solid. Okay, then that resulting solution is called as a solid solution. Now assume that if here in the gaseous solution, in that the solute, whatever it is there, the solute may be here the solid, liquid, or gas. But in this case, the solvent should always in the gaseous form. Okay, so this is how the solutions are classified. Now the solutions are classified depending upon the nature of the solvent. If the solvent is liquid, you can see that the solvent is liquid, then it is called as a liquid solution. If the solvent is solid, which is called as solid solution. If the solvent is gas, then it is called a gaseous solution. Okay, I don't think that the solvent, whatever we take, is always a liquid. It may be a solid, or it may be gas. It may be anything. Okay, we'll arrange some examples for this. On that basis, we can conclude this classification more perfectly, students. Let's see some examples here. Examples for liquid solution. Examples for liquid solutions. Okay, so in this we'll discuss. So what we discussed in this, whatever the solute is there, check the solute what it is. The solute may be here solid, or it may be liquid, or it may be gas. It may be anything. Okay, but what should be the solvent? Yes, the solvent should be always, that should be liquid. That should be always liquid to result a liquid solution. We'll take example here. The first example where solid plus liquid is there. Liquid. This side I am writing here solute, and this side I am writing here solvent. Example is for the solid dissolved in a liquid is sodium chloride NaCl dissolved in water. A result here liquid solution. Results liquid solution. Hope you understood this part. Okay. Next one, if I take here, instead of taking solid in liquid, I will use here liquid dissolved in liquid. Okay, so better I will write here, this one is solvent, and this one is liquid. This one is solute. Now liquid dissolved in liquid means alcohol in water. Alcohol in water is a classic example. Okay, results here liquid solution. Okay, and there is one more example is there, that is gas dissolved in liquid. The gas should be in a smaller quantity, like that is oxygen gas, O2 gas in water. I think you know that in the aquatic animals, in the water, whatever the aquatic animals exist, they breathe the oxygen which is dissolved in the water. So continuously from the atmosphere, the oxygen is get dissolved in the water, and that oxygen is consumed by the aquatic plants and the aquatic animals. Okay, so this is what even you can take one example, that carbon dioxide, when you dissolve in water, it forms a carbonic acid. That is also a form of liquid solution. This form here liquid solution, student. Liquid solutions. So remaining thing we will discuss in the next video, students, like how the solid solutions are present, and how the gaseous solutions are formed, and what their compositions are there, and what we can take examples for that. Thank you, students, for watching the video.